This tortoise was given the name Indo-Chinese box tortoise by the first scientist to identify it in 1939, Monsieur Bourret. He also gave it another charming nickname, Coura galbinifrons. This has been a tradition since 1758, introduced by the scholar Carl von Linnaeus. Every living being is given, apart from its usual name, a name in Latin, which defines its genus and species. At that time, Latin was the universal language which allowed scholars to spread and share their knowledge. We continue to use the same method today, with more than 10,000 species discovered every year. The same procedure is always followed. Once a new specimen has been identified, and if it is the first of its species to be identified, the discoverer publishes a scientific article to describe it. The specimen which was used then acquires the status of type. In other words, it becomes the object of reference and comparison for all scientists. This particular object, a Coura galbinifrons tortoise, is the type of its species. It is preserved in the Museum of Toulouse. Researchers can consult the publication, or even better, come to study it in situ. In 1809, the French naturalist Jean-Baptiste Lamarck turned our whole conception of the animal world upside down. He put forward the idea that species transform over time, and proposed the law of use and disuse in order to explain the evolution of species. Let us take the example of the dodo of Mauritius. In the absence of predators, the dodo lost its wings over a few million years. In 1859, Darwin proposed another theory. Species evolve by natural selection. A striking example is that of the peppered moth. This English moth is mostly white in color in order to camouflage itself when on the bark of birch trees, thereby escaping detection by its predators. By the end of the 19th century, the smoke from the factories of the Industrial Revolution had caused the trunks of birch trees to blacken. This change favored the rare black-bodied peppered moth, which suddenly became less visible to predators. Little by little, the white-bodied peppered moth disappeared from industrial regions. The transformation of the species resulted from the selection of those individuals best suited for survival. Ideas about evolution lead us to rethink the relationship between current species. Even though the name of a species, for example, galbinifrons, will never change, it can change genus if it is discovered to be related to other species. This was the case for the tortoise Anamemis anamensis. After an in-depth morphological study, Iverson and McCord, two American researchers, discovered that it was related to another genus of tortoises and renamed it Moremis anamensis. In 1866, Gaudry was the first to link extinct species to current species. The evolution of species subsequently became the dominant factor in the classification of species. It was the only approach which mattered. With the advent of molecular biology, new data appeared. DNA, genetic information. By comparing the DNA of two species, researchers in the field of evolution can provide new data to add to the information already compiled about a species regarding its behavior, its morphology, and its relationship with the environment. In the case of our Anamemis tortoise, molecular tests carried out in 2004 confirm the name of the genus Moremis. As their knowledge accumulates, scientists continue to challenge their hypotheses due to the new information collected. Certain hypotheses have been called into question, and indeed, some have come into opposition to each other. But in the end, what is at stake remains the same: the discovery of the history of life and of biodiversity.